Hello, myself Shubham Phepade. I am a second year engineering student. I am pursuing my Bachelor of Engineering in Electronics and Telecommunication at Sinhgad College of Engineering, Pune. For my internship presentation, I have created the PPT about what I learned in the whole internship, and at the last, I have demonstrated the project demo which I did using the MP Lab and Pixim Lab simulation board. So let's start with overview of the internship. So in first week we were taught about the introduction to the C language. So the basic concepts were cleared. We introduced to the embedded C, microcontrollers, embedded system, what project we are going to build. It details its demonstration. So the purpose of the project, well, it focuses on simulating a washing machine using a Pixim lab. So the simulation project provides valuable insights into washing machine operations, control system design, and simulation techniques. C programming language. So it's a general purpose language. Even though it is applied and used effectively in various specific domain, it is a procedural programming language, meaning that it follows a top-down approach. And C is often referred as a middle level language because it combines low level features as well as the high level features. So where it is used in the embedded systems, system software development, firmware, middleware, and driver development, firm system development, database system, compilers, and development tools. So there are various types of keywords in C. The data types are character, integer, float, double. Modifiers are signed, unsigned, short, long. The loops are for, while, and do while loop. For decision we use if statement, else, switch, case, and default. Derived types are struct and unions. User defined are enums and type defs. These are the main keywords in the C. So what are the data types in C? It specifies the type of data that the variable can store, like integer, character, or float. So int have 2 to 4 bytes, float have 4, double have 8, and character have 1 byte. So what are the types of constant? So there is a integer constant, character constant, and floating point constant. About the variables, it is a memory location with some name that helps us store some form of data and retrieves it when required. We can store different types of data in the variable. So the types of operators. So C language provides a wide range of operators. We have increment or decrement operator, arithmetic operator. We can use maths using these arithmetic operators, relational operator to see whether the given number is greater than or equal to than the mentioned number. Logical operator, we can use this in the if-else statements. We have bitwise operator, assignment operator, and also a conditional operator. So what is the basic anatomy of a C program? So first we declare the preprocessive directive. In this program it is hashtag include stdio.h and conio.h. So function heading will be int main. Then we will declare the variable. So here it is int number 1, number 2, and sum are the variables. So we are taking the input of two integers. So it is mentioned printf into two integers. Then we have used the scanf function. Then we will calculate the sum using sum equal to num1 plus num2. Then we will print. So this is the sub program of the C program. So now let's move on to the control statement decision making in C. So first we have if statement. The if statement allows us to execute a block of code if a specified condition is true. Here is the flow diagram of the if statement. So what if else statement? If the statement allows us to execute one block of code if condition is true and another block of code if the condition is false. So this is the if else statement. So what is the else if statement do? The else if statement allows us to test multiple conditions and execute different blocks of code based on outcome of these conditions. So now we have loops. The for loop in C language provides the functionality or feature to repeat a set of statements a defined number of times. The for loop itself is a form of an entry controlled loop. So what while loop? A while loop is a control flow statement that allows us to code to be executed repeatedly based on given boolean condition. Do while loop. Do while loop is similar to while loop with only difference that it checks for the condition after executing the statement. Therefore, it is an example of exit control loop. So, break. The break statement is used to immediately terminate the loop. When encountered, break exits the loop and control transfers to statement immediately. And what is continue? The continue statement is used to skip the rest of the loop body for the current iteration and move to the next iteration. So we have written a for loop for printing 1 to 10 numbers, and we mention continue equal to 3, then it will skip the 3 value and it will print from 1 to 2 and 4 to 10. It will skip the 3. So this is what continue statement does. So ternary operator. The ternary operator, you can also call this as a conditional operator. It is a compact way of writing conditional expressions in C. It is the only ternary operator in C that takes 3 operands. So we have a condition, expression 1 and expression 2. So in this program, we are checking whether the given number is even or odd. So we have mentioned it by using result equal to num modulo 2 equal to 0. So if the remainder of the entered number is 0, then it is an even number, or if it doesn't, if the remainder isn't 0, then it is an odd number. So arrays in C program. In C, an array is a collection of elements of same data type stored in contiguous memory location. As you can see in the program, we have defined a number of array. Int number, the size is 5, the array is 10, 20, 30, 40 and 50, and we have given the for loop and we have to print the elements of the array. So using for loop, we are printing it. So we have taken int I is equal to 0 because the index starts from 0, and I less than 5 means it will print from index 0 to 4. So this is how we get the output of the elements in the array. So pointers in C program. Pointers in C are variables that store memory addresses. They are powerful features of the language that allow for dynamic memory allocation, efficient manipulation of data structure, and direct access to memory location. Hash include stdioh. So we have used the precursor directive, then int main, we have declared the int number is equal to 10, then we will use int asterisk ptr to declare for declaration of pointer variable. Then we will assign the address of number to the pointer variable by ptr is equal to ampersand number. Then we will access the value of number using the pointer, that is printf value of number %d using asterisk ptr. Then we will modify the value of number using the pointer by asterisk ptr equal to 20. So this will give us the number, the value of number is 10 and modified value will be 20. So next we were taught about the embedded system, its introduction. So embedded system is a computer system that has dedicated function within larger mechanical or electrical system. It is composed of hardware and software components. It includes memory, bus, input output controller, where embedded software includes embedded operating system. So there are various types of it. We have real-time embedded system, which will complete the task within the deadline. So for example, let's take a missile system. It is a system which will complete the task within the deadline. And we also have airbags. And next, network embedded system, which can construct to other devices and able to transmit data and receive. Then we have mobile embedded system, which you can carry it from one place to another. So what are the components in the embedded system? So we have the microcontroller or SoC or microprocessor. We have digital to analog converter called as a DAC or ADC, analog digital converter. We have actuators, sensors, auxiliary system, diagnostic port, ASIC and memory. So now let's move on to the microcontroller. It is an integrated circuit which is capable of being programmed to perform a specific task. The design has restrictions like memory size, input output, capabilities, and peripheral functions. So there are two general architectures. First, it's von Neumann architecture. It basically shares signals and memory for code and data. And then we have second Harvard architecture. It physically separates signals and storage for code and data. So what is the difference between these two, microcontroller and microprocessor? So in microcontroller, all components are in a single chip, and in microprocessor they are separated. Microcontroller is less flexible while the microprocessor is more flexible. Microcontroller has less design complexity, but the microprocessor has more design complexity. So how do we choose a microcontroller? So there are various factors which depends while choosing the microcontroller. So first is application. So what kind of application you want to achieve using the microcontroller? So this is the main point while choosing a microcontroller. And next is performance, how it is performing. Then next is the price. So at different price the functionality of a microcontroller changes. So and then availability, we have to check whether it is available or not, also the availability of tools, and it has some special capabilities or not. So now let's move to the project part. So what is the problem statement we are having? So we are aiming to replicate a real world washing machine functionality in a virtual environment. So what are the tools we are using? So we are using first a PIC16F877A board, MPLAB IDE, X8 compiler, using switches, CLCD, timers, buzzers, and motor. So what are the functional requirements? So as you can see, this is the block diagram of the program. So the functional requirements are the power on, the pause or stop screen, navigation, the door status, and the display of the washing status. We need a buzzer and a motor. So these are the functional requirements of the microcontroller. So now let's move on to the block diagram. So this is the block diagram of the 16F877A. The block diagram is referenced using its datasheet of the PIC16F877A board. So here you can see the specifications of it and its connections. So let's talk about the PIC16F8 board, its information. So it is based on Harvard architecture. It features 8-bit RISC. It has a 14 KB of flash program memory and 368 bytes of RAM. So the peripherals here, it have timers, analog to digital converter, that is ADC, USART, I2C, watchdog timer, that is WT, and interrupt controller. So power management, it also have power management. It offers several low power modes for power efficient operation. So here you can see the output images of the program. So first is the power on screen, then the powering on screen, then washing program screen, water level program, then we have start screen, door status screen, function screen, program completion status. And for the conclusion, so this is the washing machine simulation using PixelLab serves as an effective tool for learning and applying concepts in embedded system. It offered a hands-on experience that complemented theoretical knowledge and provided foundation for further exploration in the field of automation and control system. So this was the part of the PPT. So now we will move on to the MPLAB IDE and then PixSimLab. And this is our MPLAB IDE. So here we have written the code. This is our main.c file. So and this is the washing machine file, and here we have the source file. We included the .c files like digital keypad.c, ISR, timers.c, clcd.c, and above there are its header files in .h format. So this is our main.c program, which is used to simulate the program in the PixSimLab simulation board. So this is the entire program we were taught in the internship, and this is the header file of the main. So here we have defined, and this is the digital keypad.c, digital keypad.h, we have clcd.c, this is the clcd.h file, this is timers.c, this is the timers.h file. So after completing the code, we will clean and build. So in order to make the hex file, so we will now right click on the washing machine and go to clean and build. If the build is successful, we are ready to simulate it on the PixSim lab. So it is getting loaded. So as you can see here, the build is successful. So now we can use this hex file and load it in the PixSim lab simulation board. So now let's move on to the PixSim lab. So this is our PixSim lab simulation board, and here you can see all parts. Here are switches. This is switch 1, 2, 3 and 4, 5 and 6. You can also see a buzzer here and a fan. And here we have the display where our output is shown. And for microcontroller we have chosen PIC 16F877A, and we have set the clock frequency to 20 megahertz. So as displayed in the LCD, it is telling us to press the key 5. So firstly we will load the hex file by clicking the load hex, and then we will open it. So this is how we loaded our hex file. I will just reset it. So it's showing us to press the key 5. So now we will press the key 5 to turn on the washing machine. So this is our switch 5. So now it is getting power on. So there are various programs in the washing machine, as you can see here: daily, heavy and daily kits. There are also more options. Currently daily is selected using this asterisk. To navigate we can use switch 4, and we will also be able to see other options as well. So as I scroll down, I am getting heavy, delicates, whites, stain wash, eco cottons, woolens, bed sheets, rinse plus dry, dry only, wash only, and aqua store. So these are the various options in the washing programs. So for now we will select heavy. To choose the heavy option, we will long press the switch 4 unless we get the water level screen. We will keep long pressing it. So as you can see, we are getting the water level. So now it is currently selected auto. We can also set it to low, medium, high and max by navigating using switch 4. So as you can see, so for now we will set it to high by long pressing high using the switch 4. So I am long pressing the switch 4, and it will give me a start or stop screen. So as you can see, I can start the program by using the switch 5 in order to stop it, because if I did a mistake while choosing washing program or water level, I can again reselect it by pressing switch 6. So now I will press the switch 6 to go back to select the washing programs. So now it is again bring back me to the washing programs. So now I will select some other option. I will select stain wash for now. I will long press the switch 4, and now I will get the water level screen, and I will again choose the high level. And now I will start the program using the switch 5 to start. So I will just press it. So now as you can see, we are getting the function wash, and time remaining is to complete the program is 1 minute 30 seconds. And as you can see, the program is running because the fan has started to move. We can also pause this program using the switch 6, as you can see in the display. So now you're seeing the function wash is going on. So after some time it will change to rinse and then it will spin. So for now let's pause the program. So see, the program is paused at 1 minute and 8 seconds. In order to resume it again, we have to use the switch 5. So now the program has been started. So this is our switch 1, which shows us the door status. So if I press it, the door will open and the program will stop. The timer will also stop. So I will just show it. So now I have pressed the switch 1 and the door is open. So the timer is also stopped. So when I release it, the timer will start from the time it was stopped. It will resume it. So as soon as I release it, the program has also started again. So currently function rinse is going on. When time remaining is 10 seconds, it will start to spin. You can see that in the functions. So we can still pause it or resume it as our wish. So let's resume it for now. We still have 20 seconds to run our program. After that, program will be completed. So as soon as it get to 10 seconds, the function will change to spin. So now it has started to spin. So now our program is completed and it is telling us to remove the cloths. And see, it has bring us back to the washing programs to choose another options and start the procedure again. So this is how we implemented the washing machine using the microcontroller PIC16F877A. So I once again thanks EMERTXE to provide me the opportunity for this internship. Thank you.